Welcome everybody. Thank you for registering for our webinar on PROINSO mounting structures, how to size, analyze and design. Our presenter today will be Ana Lizar, who is from Spain. She's from PROINSO PV and is a qualified architect, and she has control over the structures, and she'll obviously take you through a bit more information about the structures and the offerings that we do offer. We have quite a few registrations obviously on the webinar today, which is great. Let me just first walk you through how to use the software. If you have any questions, there's a little box where you can raise your hand. So if you have any questions, just click on the raise your hand and one of us will surely definitely see that you've raised your hand, and you'll be able to ask your question at any point during the presentation. If it's any sort of long-winded question and that sort of thing, please hold it to the end, and where we will obviously go through questions one by one, and we'll have a panelist will be able to answer those questions accordingly. That's basically how the software works. I'm sure everyone can hear me all right. Everyone is on mute so that we just drown out any background noise, and I trust everyone can hear me all right. So obviously today we'll be presenting on PROINSO PV, which is our solar mounting structures. It's a very good product. We've had a lot of development in these products over the recent period, and obviously that development is going to expand continually, and as we develop the product range and the product itself. We've had a lot of success installations on these structures in South Africa, as well as Southern Africa as a whole and globally. Obviously in this context we're talking about Southern Africa, and we've seen them integrated and installed on various installations, and we're very happy and very proud of the structure, and obviously Anna will take you through the technology of that shortly. Before I carry on and just hand over to Anna, obviously if you have any questions on the structures or anything, or pricing or anything, please feel free to contact any of our support staff, our sales staff. You can get all the information on the website. I'm sure most people on this call will have the information already, but if you log into the website, you can then get, obviously, you can pick up everything that you need to know, as well as if you go into our click and collect store, you can also obviously view some information and that sort of thing on the products. So before I take up any more time, I'm going to hand over to Anna. Anna is from, she's based in the UK, from Spain, and Anna will take you through a little bit further. Over to you, Anna.
Thanks for the introduction, Russell. Okay, and now I'm going to show you a short view of the products of PROINSO PV Rack, that is a subsidiary inside PROINSO, responsible of the racking system. Okay, mainly we are going to break down this presentation in 3 easy to understand sections that are how to start. We are talking here about the basis of the calculations, then how to choose the best kit, and after that, how to install it. Okay. So in this how to start section, we want to show you main considerations that involve the calculation process. Depending on each of the points that I'm going to be focused on, the structures will have one configuration or another. Okay. We are going to pay attention to the influence that the locations have inside the project final configuration. Inside the location data, the most important points are the following ones: the building conditions, the layout of the roof, the wind and the snow loads, the corrosion and the tilt. As well, the standards of the different countries to apply are important. However, we are now going to talk about South Africa, so we are just assume this is the one that will apply to simplify all the presentation. Okay. So inside the building conditions, we are going to separate it in 2 different steps. The first one is the base of any PV installation, is the orientation that our modules will have to ensure as much production as possible for the conditions we have. The theory told us that we have to have an optimum angle with the sun. That means during the different seasons of the year, the sun height changes. Being in the summer, as you could see here, okay, in the summer is the highest one, and in the winter you have the less high. as we are now talking about South Africa, our modules have to be always orientated to the north, okay? And the other side of the equator is going to the south. And to optimal field, you have easy formulas that you could get over Google, okay, and you will get it. The second step inside the building conditions is related to the measurements of the building. For example, the distances between the purlins that is related directly to, obviously, the points of the where our fixings are going to be placed. The height of the building that is directly linked to the wind loads that we will have, and as well with the wind loads is related the slopes or the tilt that our roof is going to have. The last point is the type of the roof that we have. That depends on the material of our roof. Obviously, our fixings are going to be different. The layout of the roof. When we do the layout of the roof, we have to take in consideration some elements that could give shadows to our PV modules, okay? As well as related these shadows with the pitch between the rows of modules we will have. The pitch is the distance between one row and the next one, okay? And as well, the position of the modules could be in landscape or in portrait. Obviously, the portrait that we are going to take the length of the module will take more pitch between rows because the shadow we will extend for more distance. Remind you again that always has to be faced to the north. Okay. As I previously said, the wind loads are really important for the structure configurations. Here you can see how the winds affect the module surface. Okay. Here our modules are tilt. However, there are some cases that we have a coplanar and the roof times directly in the same plane as our modules, okay? But you could see here how the forces against the wind loads, works. If we have some free space in the back of our modules, maybe we will have some uplift forces, okay?
Anna?
Obviously, well, I think here in South Africa you will not have, guys, any snow loads, okay? So we are not going to talk about the snow loads in this case.
Anna?
Yeah?
This is John, right? I just want to ask you real quick, if you can just go back to where the roof, the sizing of the roof and that, the second slide. Could you just give us a little bit more details on, the previous slide? Yeah.
Okay, here.
Just a little bit more details on, for example, the difference between steel and wood and the substructures, and if you could just give us a little bit more details on these.
Yeah, well, mainly the industrial roofs, okay, the metal sheet roofs, has purlins distribution above it. And we have to take into consideration that in this case, as you can see here in the drawing, the purlins came in the length side of the building, but sometimes as well they are in the opposite one, okay, perpendicular to this one. Okay, so as we are going to fix our structures to these purlins, we have to have like a layout, or the architect of the building layout could, I think, could give us all this information, okay? Because sometimes, depending on the wind loads, we have more or less fixings in our structure. That means, if, for example, in this case, there will be no troubles because you could place, any distance will be required, your fixes in here. However, when the purlins are in the other side, okay, in the other direction, maybe the distance between the purlins will be, let's say, 1.5 meters, and our requirement says that should be within 1 meter, okay? So sometimes, maybe in these cases, we have to put a double structure in the racking system, okay? In the cases of the residential roofs, or the roofs made of wood that usually are residential, it's same. We have the rafter and the purlins made of wood, okay? And usually, as for my knowledge, they have a double structure. One is, they already have, I mean, both types, you know, in this direction and in the other one. And depending the type that we will have, we could fix it to the rafters that are in the white direction, or we could fix it in the length one. We always recommend to the perpendicular one, because it's the one that could support better all the loads that we are going to transfer to the structure of the building. Okay, so they are the same in the residential case. The wood material is always the same. I mean, the same as we say previously to the industrial roofs. It's like, for example, imagine that the rafter came in every 1 meter, and we need, because of the wind loads, 700 millimeters, okay? So you have to place one in this one, but the next one don't have rafter. In this case, the solution is really easy, because you could put a piece of wood that link one rafter and the next one, and you can place your fixing in the middle, okay?
Sure.
So I think this is the consideration for almost all of the kits, you know, because they are directly fixed to the substructures. So obviously it's one thing to take into account, and really, really important. Imagine that you go to the top of the roof to do the installation, and you have not the purlin to be installed in. So maybe there will be some issues in this way. Okay.
Another question that we have real quick is what is the height of the building? How does it affect the system? How does it affect the structure of the roof? The height of the building?
The height that we take into account for our kits is 10 meters high. All the heights that will be less than this, our structure has been designed for more, so there's no troubles on the loads that they have to support. But the more height that you have, the more wind loads you have to support. This is the standards give you some instructions in how to calculate the structures to put in the buildings, okay? So the standards usually say if you have this height or above this height, you should apply this coefficient. If you have more than 10 meters high, you have to apply this one. Obviously, as you increase the height, they increase as well the coefficient that you have to multiply your structure. Okay.
Okay. Okay.
I don't know if it solves the doubt or not.
Yes. 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 Thank you. Thank you.
Okay. So yeah, I think it's always related to the standards. Okay, this kind of the time material, the height of the buildings, and the distances between purlins, you know, as well has some considerations in the standards to apply. Okay. So after the wind loads, let's go to the corrosion. The location as well is related to the corrosion caused to our structures. Is mainly in zones that is close to the coast and the ones close to the industrial areas. Okay, here is a map of South Africa, taken of the standard, and as you could see here, the nomenclature they use for the corrosive environments. The C1 is the less one, and the highest one is in the coastal areas. That is caused because of the salt that the air has, okay? And the industrial areas, obviously, is because of the pollution that they have. Anyway, in our case, our structures are aluminum ones, and we have an extra coating, nanonite, that involves more year of life to the components against any corrosion defect. Okay.
And now sorry, can you just go back a slide quickly?
Yeah.
Yeah. So just to go through the corrosion and that sort of thing, can you just explain to us sort of the role that corrosion would play in a system installation. I'm sure a lot of the guys are quite interested. A lot of them have installations on the coastal areas, and some of them obviously install with galvanized steel, etc. So can you just explain to us why aluminium and what the role corrosion can play in the system? Obviously, we know sort of what corrosion does, but just from your perspective, that would be great.
Yeah, well, in the hot galvanized steel and the most of all steels, the corrosion is always a layer that appears just in the first layers of the steel, okay? It involves that if the coating that we have is beaten, okay, to say something, by this corrosion, and at the end, maybe in each couple of years, the features and the loads that this steel could support from the calculation up to the moment that the corrosion will come would decrease, okay? So decrease the capabilities of the steel that we have. In the aluminium, well, as you already know, is one material that has not any influence, I mean, the corrosion has not influence on it. However, if some of this corrosion appears, these rusty surfaces don't cause any less capabilities of the material. I mean, it don't affect so much in the material strength, okay? However, the anodized coating that we apply is just because these visual effects that you could see, some rusty areas or something like that, and well, it's to give a little bit more of quality to the product, okay? Because, well, if any of these visual effects could come in the aluminium, if you anodize it, it's not going to appear, okay? And could as well give some more longevity to the structure, but if for aluminium we are talking about 15 years, maybe we are talking with the anodized coating 20, 25 years, okay? As well, always depends, because if there, for example, not in coastal areas, but for example in the industrial areas, imagine that you have a huge level of pollution, maybe some rusty surfaces could appear if you have the anodized coating, but this is a really weird, you know, have to be high level of pollution, okay? But just clarify that this is the steel structures that could be damages on them. In the aluminium, there's not this kind of issue, okay?
Perfect, thank you, Anna.
Okay. And now, this is the last point for the location considerations. Is the last but not the least important, and it depends directly of the steel that we decide to put in our installation. For the flat roofs, obviously, we have to install the angle, the optimal angle, or as much close to the optimal angle as we can. However, for the pitched roofs, or the ones that already have some angles, depending on the orientation that they have and the distortion with the azimuth, because always, you know, our roofs are not pure orientated to the north, okay, unfortunately. We have to put some additional degrees for the ones that the building has. That means, for example, imagine that here, if we have this double pitched roof orientated to the north, okay, we could install here our panels directly with the angle of 34 degrees, okay, and get it the optimum one. But imagine that the north in this single pitched roof, the north is in here. If we have already some tint, we have to get the optimal one to be perpendicular to the sun. So it would be an additional tilt to get, imagine that in our location we need 20 degrees, okay? So we will have the 20 degrees to be tilt plus the one to cover the tilt of the roof in one side and the next one, okay? So I don't know if it's clear that. I think it's a common thing, you know, that sometimes, I think I have another slide that you could see here, for example. Here you could see, okay, this would be this kind of solution that you have to put an additional tilt to get the optimal one, because obviously your slope is going to the other position. Let's say here north, guys, because these kind of drawings are for the different countries that you have to put your modules south facing, okay?
Anna, just quickly, just back on the tilt. And let's say, for example, just to understand correctly, you've got the single pitched roof, right? And I see on the pictures there.
Yes.
Does the structures allow to add a bolt to increase the degrees of the structures?
Yes, in these cases, you could use the triangle solution, okay, to save this tilt, okay? And could be directly, if it's a metal sheet, we obviously have to be double check. This kind of products, we don't have kits already calculated for this, because every single different roof is different and the loads are going to affect different. So we prefer that the client send the RFQ, okay, the request for information, and we will calculate it and customize these structures just for this single project, okay?
Yes, cool. Thank you. Thank you, Anna.
Well, after these considerations, the next step is how to choose the appropriate kits, okay? In the following slide, I'm show you the current products that we have. However, well, we are working in further products that we expect will be launched in September, so maybe we will have another webinar soon about the new kits, okay? Our kits are customized depending on each country specifications. So in this case, for South Africa, we have the following ones. All of them are aluminum 60, 63, T5, and the anodized coating. Okay. Here you could see is the IBR, the Spanish style triangle, thin corrugated that we sometimes call hanger bolt, clip lock, and finally the mini wheel. This kit has been designed to have all items needed for the installation in a compact box, doing easy to take to the top of the building for installers, and as well have some of these main instructions to assembly steps inside to make your all your work even easier. Okay. Well, and after this short presentation of the product, let's start choosing, okay? Let's go. The IBR one, in which buildings is the best option to install this IBR kit? This kit has been designed to could be installed in almost all the metal sheet that we have in the market that you could see here. Any shape that will be required could be installed, okay? The only consideration, as I previously said, is the distance between the purlins and the position of them, okay? Remind this because, well, sometimes if there are some issues, you just have to double check with our technical team and we will give the best solution if you have not the space required, okay, between them. This kit is an L connector and a self-screw, okay, and allows any position of the modules. One would be the portrait one, sorry, here, and this is the landscape position. The next one is the tile as well, designed for almost all the tile versions that we could find in the market. The only thing that we should take into account is the distance of superimposition that we are going to have between tiles, because I will show you then the fixing piece that we have. We have already a length, okay, of the fixing, and sometimes if you have a superimposition of more length of this one, that should be revising, okay? And as I previously mentioned, the distance between the rafters, because obviously is the point where we are going to fix our structures. In this case, the configuration that allows this kit is going to be the portrait one, okay? In the triangle
sorry, one second.
solution,
Can you just go back
yeah.
to tile?
Yeah.
Yeah. So just to discuss the number of fixing points in comparison between the previous sort of sheet metal mounting, the corrugated, and the tile. Can you just explain the different number of fixing points and the implication that that has, obviously?
Yeah. For example, in the case of the IBR, I think we currently have for South Africa for 180 kilometers per hour in wind loads. We have 5 fixing per rail. That means 10 in total. Okay. This kind of fixing, and it's self-screw and directly goes to the purlin, is a little bit weaker between brackets. Okay, that the tile is. These tile pieces are made of steel because would support more loads. The aluminium sometimes for this kind of load transfer could be risky for the tile version of the kits, and I think all of the solutions in the market for tile are steel ones. Okay. And in the case of the tile, as we could support more loads per fixing, I think we are using 4 in each rail, so 8 in total. Okay. As well as is linked to always to the loads that we will have. Imagine that we put in the tile version, we put it already peeled, okay? Obviously these loads are going to be higher, so maybe we should put more points of fixing, okay? So you could see, I will explain you as well in the next one, that is the hanger bolt, is the exactly same solution. Here you could see it, sorry. Same solution, okay, as the IBR. The only difference is the hanger bolt. Instead of the self-screw, it's a hanger bolt that goes directly to the purlin. This method as well is used for the main types of metal sheets. However, they could support more loads. They are stronger, okay? So that involves the number of fixings per rail or per total kit is going to be less for windows that the IBR would involve, okay? And to go ahead with the triangle one, the triangle one has been designed perfectly well for the flat roofs. However, as well we could use it in the metal sheet ones, as I previously said. You know, has to be checked by our engineers, but it's possible. So you could see in here that the customization of the kit has been done with a foundation of concrete slabs and a G-bolt, but as well being double checked by our technical team, could be installed directly to the surface of the building. Okay. It depends as well of the capability that the surface has. It could be penetrated. If not, you know, there are a lot of, I think, things taken into account in this case. And you could see here, now is one new, quite new thing that we have applied to the triangle kit, that is the pieces in the back are flexible now and allowed to adapt any type of angle, okay, in our installation.
Anna?
The hanger bolts.
Just quickly on the triangle.
Yeah, tell me.
I just got a question real quick. Can these, without the concrete blocks, can these be used as, for example, as a ballast system on a flat roof?
Yeah, for sure. I mean, the concrete slab, the only thing that would be is the same, is the working system is the same as the ballast system. The thing is that obviously this concrete slab involves some civil on it, but it's completely the same. I mean, if you put, for example, some additional rails in here, in the surface, imagine, you know, connecting one portal frame to the other, you have a surface in here and you could put all the weight necessary for the specific location, again, the wind loads, and that's all. I mean, it's so easy to fix this kind of things. Mainly, as said is we were thinking in doing with concrete slabs because it's the worst case between brackets, okay? That is the civils, but I mean sorry, instead of the concrete slabs, if we put some additional weight to this and we distribute it through all the surface, is allowed, and as well directly to the surface of the rooftop. Okay.
Okay. Thank you.
Well,
thank you,
but the hanger bolt solution, as I said before, is customized for maybe areas that we have more than 180 kilometers per hour, because by this way we reduce the number of fixings or points of fixing that we will have in our structure. Would be installed in any of the metal sheets that they are in the market, and allows us to put in portrait or in landscape. Okay. The clip lock solution. Yeah, tell me.
Just one more question back onto the ballast. We've got a question here that is just it's asking: is there a guideline on calculating the ballast requirements?
It's complicated to say this because the ballast requirement is directly linked to the loads that we will have. So that involves, you have to take into account the tilt of the structure, the height of the building, and by this way we will do the calculations for the loads that are going to be transferred to the bottom of our structure. Okay, when you have these reactions in the bottom side, you have to calculate the weight to avoid that this structure go up. Do you know what I mean? Because the air comes to here and have an uplift forces. Okay, so if the dimensions of your weight are X or Y, okay, you avoid that this structure will goes up. Okay, it's the same as if you try to jump and someone puts some weight in your shoulders. Okay, it's the same, exactly the same. So there's some instructions, but there are specific formulas. Okay, that obviously has to be done by engineers. We could not give you like a general or a standard, you know, saying X kilos per X tilt. No, because maybe if your wind loads change, obviously this weight is going to be reduced or is going to be higher. Okay. So but anyway, in these cases that there will come some doubts about it, just feel free to contact us directly, saying, guys, I have this specific location, and please tell me the weight that I will need per the total clips, you know, and that's all. We will calculate it and give some advice on it. Okay?
Okay, thank you, Anna.
Going through the clip lock solution, the most simple one, and I think it is one so famous in South Africa, right? We have designed this piece that could be adapted directly to the shape that our clip lock roof is going to have. Okay, and it allows just would be for clip lock solution. I mean, if you have here the image is the shape of the head, so any other metal sheet that have different shapes would not be adapted for this clip lock one. Okay, and allowed us to install it just in the portrait, in the landscape position. That is caused because of the distances that you have between each one. That would be 406 or 700, okay? The different type of the clip lock that they are in the market. And finally, the mini rail. The mini rail, well, as you realize later, okay, is my favorite one. Is the one that came, everything is inside the box, as well the the rails because they have different lengths but so small. Okay, so everything comes in the box, so easy to keep it wherever you want it. Okay, and could be installed for any type of trapezoidal shapes. That means if you have different angle in the trapezoidal shape, or you have a different length, imagine that you are going to use the L connector, but there's not enough space in here, okay? This kind of solution allows you to install whatever will be the shape of this trapezoidal sheet because could be adapted, okay? And one thing that we have to take in consideration is the thickness of this roof. Why? Because the less thickness it will have, obviously the weaker the roof is. Okay, so we have to ensure that has more than, I think it's 2 millimeters one, and at the loads that we are going to transfer to this roof, obviously the sheet could support it. Okay, is the only solution that is not, well, as well the clip lock we mentioned previously, but it's the only one that don't need any consideration in the purlins. It goes directly to the surface of the roof, okay? Don't go directly installed to the purlins. So that's why it's the most flexible solution, okay, for the industrial roofs. This kind of solution allowed us to install in portrait configuration, okay? That is just cost because the slope of the roof is going to happen this way, okay?
Anna, what is the minimum thickness of the mini rail roof that it needs to be? Minimum?
It always depends. If you have not windows, you know, I think this sheet goes up from 1.5 or 1.2 millimeters up to 2.5, 3 millimeters. It depends. There are a lot of them in the market. Okay, we always consider, I think, the 2 millimeters one because we have some assumptions in our calculation of the kits that is, you know, gets this 120, 150. But imagine that in some areas you have, I don't know, 30 kilometers per hour, or you have no wind loads. Okay, if the metal sheet has 1.2 millimeter thickness, you could install it as well, okay? But has to be always revised because the testing matter that we do, okay, is with the up to 1.5 or 2 millimeters one, okay? But it's always a matter to calculate or to study, okay? There's no pure rules on this, okay?
Thank you, Anna.
Now, after having looked at this overview for the products and basis of all the products, let's see how I'm going to store it is the next question, right? So our kits are really simple and easy to install. And before I will start with the assembly instructions, I want to clarify that, for example, for the installation of the clamps and the method of connection between two rails is always the same. So I'm going to keep these 2 points that are the last 2 steps of the installation. I'm going to keep it by the end of the presentation, and I am going to separate each kit up to the moment that the rails are installed, okay? And then, as is common, these steps of the clamps and the rails is common for every one of them, I will go through them, okay, at the end. So, the tile kit. The tile kit comes with 3 different items inside the box that we always recommend to assembly before you go to the top of your roof, okay? As you could see in here, is so easy. You just have to tighten the screw and the washers, one in the bottom and the other one in the top, and the final piece have to look like, as you could see in here in the top, okay? When you have all of them assembled, is the moment to go to the roof. And as you could see in the drawings, I think that's so easy. You just have to take off the tiles that you expect, where you expect that the installation is going to be placed. Okay, you take your fixing, and with a self screw, you directly fix them, screw them into the rafter. As I previously said, if your distance, for example, is 1.5 meters and is required 1.2 meters, you could see this information is shown in our assembly manuals, okay? However, if you don't have it, okay, if you have not enough distance, you put a piece of wood in here, okay, you fix it properly, and you could put a fixation in the middle, okay? Obviously, always we recommend you ask us any question, and we could revise all the installation before you do something that maybe, could get some issues. When you have already placed the fixings, ensure that they are aligned, okay, in the same line, because if not, obviously, you are not going to have your installation completely straight. Okay, the next step is, you could see here the shape that our rails have. Okay, this shape that we have in the both sides and in the bottom is designed to slide the screws of our installations through them. Okay, so in this case, to install the rail, you just have to put one of the screws, slide it up to the correct position, okay, and when you have placed in the correct position, you just have to tighten it, okay, screw it, and that's all. Go to the next one, and you will have your installation with already the rails. I remind you that now I'm going to stop in this step, okay, and after all the explanation of the kits, I will explain you the next step, that would be install the clamps, okay, and the modules. The hanger bolt solution. The hanger bolt solution, well, here is the example of the corrugated roof. As well, you could see here for tiny roof as well could be installed, okay. The main difference, as we previously said, is the piece of the hanger bolt, okay, that is a stronger connection. For this type of kits, you have to go to the top of the roof and, first of all, do the setting out of the points that you are going to have inside your installation, and they have to follow a line with the purlins of the building, okay? Ensure when you do the setting out without drilling anything, setting out, they have to be aligned. When they are aligned and you have already placed where the fixings would be, you have to do some pre-drilling labors with a less diameter that the hanger bolt has, okay? You drill it, and then you have to screw your hanger bolt on it and fix the L connector on that. Just tightening it, you have the L connector. And the final solution has to look like that you could see it here in the drawing, okay? Here, there's one example of how they have to be aligned, okay? And when you have everything in place, is the moment to install the rails. As I previously said as well in the tile version, you remember you slide in the bottom shape one, but in this case, we are going to slide our screw in one of the sides, okay? So you slide the screw up to the connection that you are going to fix, and you tighten your fastener, okay? When you have everything in place, the next step would be the clamps connection.
Anna, quick question on the hanger bolts.
Yeah.
Is the hanger bolt universal for both timber and steel, or do we have two separate kits for this?
No, it's a universal steel, yeah. Okay, so it's a commercial element. Okay, so sometimes there are countries that require a longer or a shorter or a more diameter, of the hanger bolt. Okay, so we change the commercial element, and that's all. Okay.
Thank you.
For the IBR kit, IBR are so similar with the hanger bolt one. The only difference is instead of having the hanger bolt, we are going to have a self screw. What that means, we are not going to use or to need any pre-drilled works. Okay, you just have to screw it directly to the purlins of your building, and that's all. The connection piece, the L connector, will be fixed. I mean, this is one of the simplest ones, I think. Okay. As well, ensure another time that everything is in the same line, because there could be distortions in the line. Completely the same process as we previously see in the hanger bolt. You slide in one of the sides the screw, okay, up to the position that you consider the correct one, and you tighten your fixation. Okay.
Anna, we've got a quick question.
Yeah, tell me.
We've got a quick question here.
Yes.
So I'm going to unmute Nana, so you can talk. Nana, we can hear you.
Go ahead. Can you hear me? Hello. Yes, thank you. We had a question about the materials that are being used and how the mitigation of corrosion is managed where there are different metals touching each other. Can you comment on that, please?
Sorry, I could not hear properly.
Okay, I'm going to try again, Anna. We're interested to know how you manage the contact or the possibility of contact corrosion if there are different metals touching each other. For example, were you installing the rail directly, for example, to the roof bracket that you use on the tiled roof, for example? Is there any form of screening between the two metals, or is there a specific type of metal you are using?
The thing is that from my point of view, we always have this kind of event or considerations, okay, when there are metals, but in this case, the aluminium could not have, I think it's called corrosion or electrical corrosion between the two metals, is the one that you are trying for. Anyway, you could avoid this kind of effect, okay, by putting some EPDM rubbers, or, there are different solutions as well, some washers that avoid the connection between one to another, okay? It's the only, but it usually happens with hot dip galvanized steel, I think. But in the case of aluminum, I've never seen this before, okay?
Okay, thank you, Anna.
Okay.
Thanks, Anna.
Okay, with the triangle solution, this is obviously the installation is a slightly different one from the other ones because it's a triangle, okay? So, as well, easy as the other ones are. Here, I put the example of the concrete slabs because we already have the design of this, but if you have the fixing directly or wherever, you just have to place where the points of fixation we will have. In this case, you have to do previously to the installation the civils that the concrete involves, okay, with the dimension that a local engineer will give you. We have always some advice on the dimensions, but it's better to double check always with a local engineer, okay? And you will have a piece of your hanger bolt goes above the concrete surface, okay? When you have your concrete slabs already done, you just have to put the first piece of profile that already has the holes prepared for this, you place it on there and you tighten the fixing, okay? When the first profile is already installed, the next step, I always recommend to put the two ones at the same time, okay? But not tight the fastener up to the last moment. I mean, just place it and put the washer a little bit, but not tighten all the fixations, okay? Because there will be maybe sometimes that you then try to fix the last profile that you can because you have obviously already fixed the position of the profile, okay? So it's better always to put everything in place, all the washers and the screws in place, and when you ensure that everything is correct, you tighten it, okay? The next step is to put all the portal frames required, okay, and you already fixed everything, and is the moment to put the rails on. The rails as well, you slide the screw to the correct position. You already have some holes in the profile, okay, that has been designed just for the correct position to avoid any distortions or any misunderstandings in the position. As I previously said, just take the position of where the screw would be, okay, and put a little bit of washer, and when you ensure that the top rail and the bottom one are in the correct position and everything fits, tighten everything, screw everything, okay? The next step would be obviously put the clamps on. The mini rail. The mini rail, my favorite one. I think everyone should choose this one. Okay, it's the most simple one. You don't have to take into consideration any substructure, and everything comes in the box. So for me, it's the easiest one. It comes with two plates, okay, inside the box. You have different plates, and they have this kind of shape that is the same that the rail has in the bottom, okay, because after that we will slide. So we just have to put the setting out of the plates in our roof and ensure that they are in the same line to each other. Then you place with the self screws, you place them, okay, and the final solution should have more or less this, have to look like this, okay. When you have your plates already installed, the next step would be just slide up to the medium position, the mini rail that you have, and that's all. I mean, this is the only installation that this kind of product has. The only difference that could be between one sheet or another, maybe in some installations will be required a second plate, okay, that could be installed in here, or maybe this distance would be a little bit less, okay, because the different shapes that the metal sheets could have, okay. But at the end, the solution is this one. It's so flexible as well because you could put wherever will be required the number of points. Imagine that you have an area, I will say that the typhoon will come and you have to, well, I think the first thing in a typhoon is going to go out will be the roof main. But if you want to ensure your structure to the roof, okay, imagine that you have to put more points of fixations of these mini rails, okay? This kind of product is really flexible in this way that maybe another one could be installed in here, another one could be installed in here. So you could reinforce your structure in the way you will want, okay? It's so easy, I think. Another time, just a quick reminder, should be everything in the same line. Because if you have some distortions in the line, maybe here, imagine that you have some angle in here. When you are going to place your module, you will have troubles, okay? The clip lock, as well, one of the most simple ones. You just have the head of the clip lock shape, Okay, these plates come in two different ways, so you have to go to the metal roof, take one of the plates already fixed with the screw, the other one just scan it in here, adapt to the head, and tighten it. Okay, in this case as well, you have to ensure the alignment between one to each other, okay, to avoid distortions. And this method, we are now working without any rails in South Africa, so you don't need any rails to put the modules now. However, there are cases that will be required for any reason that would have, okay, and would be fixed obviously to these holes. But in the cases that we don't need any rails, just the clamp is going to be fixed directly to the clamp, okay, to the PV clamp. And now, as I promised, here is the junction between the rails. Simple steps. This plate comes inside the box, has 4 holes, okay, and will be required 4 bolts and washers. You have to screw and tighten it, and with this solution you will have, you just have to slide 2 of them in one rail on the side, and in the other one, the other 2 of them. The final solution should be like this: 2 bolts from one side and 2 for the other, okay? And that's all. I mean, it's so easy to do the junction between them. Only thing that sometimes has to be considered is that, imagine that we are going to install length. This race has 4 meters, okay, 4 meters length. So imagine that we want to install, I will say, I don't know, 16 meters, okay, so 40 in the same row. We always recommend, because of the expansion that the metal has against the heat, where the sun goes directly to them, there's some expansions, okay? So we always recommend don't put more than 10 meters length in junctions, okay, in total, okay? So if you are going to have 16 meters, you should separate 2 rails at 8 meters and 2 rails another 8 meters, and we put a distance, usually it's like 5 centimeters, it's not so much, okay, but it's enough to avoid any interface, okay, if the aluminum expands, okay. And then the clamps fixing. Here you could see the items that are required for the clamps. This is sorry, for the clamping systems, the clamping assembly. It's just, this is the middle clamp and this is the end clamp. You can realize that there are 2 pieces that you can slide to each other. This is to ensure that our structures would be adapted for any thickness of the modules we will have. The modules have 35 millimeters thickness, and other ones maybe they have 40 millimeters thickness. So this could be used for all types of modules thickness. Okay, the method is so easy. You just have to slide this spring nut that we have. Is the same method as a washer is. Okay, so you slide it through the rail, you put it in the correct position, and then you directly screw to the spring nut, and that's all. It's already installed. You have to tighten it as much as you can, and it's fixed. Okay. So I don't know, guys, if you have any further questions about all the explanations that I give, and well, I will try to answer. Okay.
Yeah. I think if anyone has any questions, you're welcome to just put up your hand. Just push the little button, and then obviously we'll then come to you and unmute you, and you're welcome to ask a question. Otherwise, you can type it in the chat box, send it to the host or everyone. That's up to you. So does anyone have any questions? Yeah, it doesn't seem like anyone has any questions to ask. If you have any further questions, think about it later today or at any point. Yeah, John Ray.
Yes, we do have one.
Okay.
What is keeping the mini rail, Anna? What is keeping the mini rail in place and preventing it from sliding out?
Nothing, because I will explain you why. The modules are going to come in the portrait direction. What that means, and the slope of the building is in this direction. So the weight of the modules will do a force in the perpendicular direction of the rail one. So that maintains the rail in the correct position. Okay, I don't know if I have explained it properly. It's just a matter of loads. Okay, if you have your railing here and someone is putting some loads in the perpendicular direction, your fixing is locked. Okay, it's not going to be moving this way because the loads always came in the perpendicular direction. The loads will not come in this direction. Do you know what I mean? I don't think if I have explained it properly.
Okay, John Ray, is there anyone else on your side that you can see?
Yes.
Okay.
Does the IBR mount have self-sealing / waterproofing?
Sorry?
So the IBR kits, right? Does the IBR kits have self-sealing or waterproofing aspects to them?
Yes, the EPDM, this here, well, I didn't mention it, but they can, sorry about that, okay, but they have an EPDM rubber in the bottom, okay, that avoids any troubles with the water to drop inside the building. And as well, the washer as well has another one, so additional one, okay, so you are double covered. Any issue with the water, okay?
Okay, thank you, Anna. I think that is it. Let's just see.
Okay, John Ray, no more questions?
We've got one more.
Okay.
Do you bolt your mini rail sides on the first slide, and then slide them into the rail, and then tighten them? So do you first bolt them, make a measurement, and then bolt them together?
Yeah, you put tight them, as you could see here, you know, if they are already fixed, and then you slide in this direction. In this direction, you slide, you know, the rail through them, because the head of this plate, here you could see the head is the same as would be a screw, okay? So you just slide them and they will be locked directly.
Thank you, Anna. Thank you. I see that we've got a few more hands here. Can we take a few more questions?
Yep, go.
Right. Okay, Clinton, I'm going to unmute you so you can ask the question, Anna. Clinton, you are live?
Am I live? You can hear me?
Yes, we can hear you.
Okay, I know the question is, we've had a problem in Namibia with the kind of structure, the mounting that you're showing us now, with insufficient clearance for cooling. Our ambient temperatures here in summer run at around 36 degrees Celsius, and some of the panels exceed 90 degrees Celsius. And we require a clearance of minimum of 100 moles to allow for sufficient cooling with regards to the panels on the roof.
So you mean that if you have, for example, sometimes don't enough distance between the roof and the module surface, they are not going to be cool, so there will be issues, right?
Correct.
Yeah. From my point of view, in this kind of installations, the better option is to use the IBR, because with the IBR, let me show you, you are going to have like 5 or 10 millimeters plus the shape, you know, the shape of the roof. So by this way, you ensure that the air is flowing in the back of the module. Okay, it's because, yeah, I understand what you mean, that sometimes if you have a high temperature, your production is going to be lower and the modules are not going to work properly because of the heat that is generated in the back side of the module. Yeah. But for this, the IBR is the best option. Okay.
If I may add to that, Clinton, if in those specific circumstances, obviously, then you run the risk of, you know, creating issues with your panels, with delamination, etc. You know, so a suggestion would be to maybe look at the hanger bolt solution, whereby you can raise the L bracket off of the corrugation and mount your panels, obviously, sort of elevated off your roof, and obviously then allow enough air movement under the panels to allow for cooling of the back sheet, etc.
Yeah, and as well, maybe a triangle, put some additional tilt or in the structure as well could be a solution, you know, because you are allowing to go the air through the back side, for example.
Okay.
Yeah. Does that answer your question, Clint?
Thank you, Anna.
It does. And obviously, any other questions I have, I'll direct directly to you two, Yandre and yourself, Russell.
Yes,
with
you're
regards
welcome
to make up a kit.
Okay, no, perfect. You're welcome to do that, and we can have a chat just now.
Thank you.
Okay. John Ray, next question.
Would a hanger bolt not work better when you need more height?
You mean if, for example, here you have, imagine that you have a really thicker purlin, you will need more length that is expected in the installation, or because I don't really understand the question.
I think, Anna, what they're meaning is exactly what we've just discussed. In terms of to get more height off of your corrugation, is to use the hanger bolt to sort of create an air gap.
Yeah, I understand.
So I think we've answered that question. Yes.
Yes.
It's like if you give the requirements that you have in a specific type of roof, okay, just to ensure that the solution is going to work properly, okay, we will study it. I mean, for example, imagine that now the kids has 20 centimeters length of hanger bolt, okay, and your shape of the trapezoidal have minimum one of 10 centimeters, and then you need 5 extra centimeters for the fixing. This is one thing that should be requested to us, and we will find, you know, the commercial element that has more length just to put you in your installation. There's not any closed item on this kind of things, okay? Because we already know, obviously, there are a lot of different rules, a lot of different things to take into account, okay? The only thing is that the kit has some assumptions on it, but if there are some items required in different dimensions, obviously we were looking after the client requirements, okay?
Thank you, Anna. I think that is it for all the questions.
Okay, this is the last chance. Has anyone got any further questions? Just raise your hand, or you can write in the chat box. If not, I think we can tie it off. Okay, I don't think it seems like anything. Nothing from your side, John, right?
Nothing from our side. Thank you.
Okay, perfect. Okay, well, I just wanted to thank everyone for your time today. I trust that it was quite insightful, and it taught everyone a little bit more about structures and the implementation on roofs. And if you have any questions, please feel free to ask us. Any of our friendly staff would obviously answer your questions and help you as far as possible. But before I take up any more of your the time. Thank you very much, everyone, for attending. And I hope we can obviously engage a little bit further on this topic. And Anna, thank you very much for your presentation and your time. Your insight is obviously always very valuable. So thank you, everybody. Have a great day further. And we look forward to hearing from you.